Hello students, welcome to this series of lectures on proper cantilever beams in structural analysis. Today we will discuss some more models or problems. In this today we will discuss this problem. This is the given problem. A propped cantilever of length 2L carries a UDL of W per meter run for a distance of L from the fixed end. If you consider here, we are considering a propped cantilever beam which is carrying a prop at the free end, that is at B, and it is carrying a UDL up to a certain distance of L from the free end. And here, if you consider here, the total length of the beam is 2L. So up to here its length is L, and up to here its length is L. So the total distance is 2L. Total distance of the beam is 2L. And I am considering the fixed end as some A. And here the end of the load, UDL, it is as some C. Now, what I had to do means, I had to draw the shear force and bending moment diagrams for this case. So, first of all, I had to find out the reactions, vertical reactions at the supports. So I am considering here the vertical reaction at A as some VA and the vertical reaction at B as some VB. And here what I am doing is, first of all, I am undergoing with solution of this case. Let VA and VB be the reactions at the fixed end A, and the property end B, So since the deflection is 0, deflection at B is 0. Now in this we had to find out the upward deflection equal to downward deflection, like in the similar problems how we had discussed, we had to do like that. Whereas here the UDL is not complete throughout this span, so it is up to only half part of the span and half part it is free. So I am writing it as WL power 4 by 8 EI plus WL cube by 6 EI. This is the slope of the other half, and into its distance, it is L, equal to, now for the cantilever beam which is carrying VB as the vertical reaction at the free end. For that you will get it as, its reaction is VB into 2L. 2L is total distance, 2L cube by 3EI. This will be the considered one. Upward deflection equal to downward deflection. From this I am solving this. I will get it as 7 by 24 WL power 4 by EI equal to 8 by 3 VB into L cube by EI. This will be the given case. In this you will get VB equal to, if you solve this, you will get it as this one 3, you will get it as 8, and here it will be 7 by 64 WL. This will be the vertical reaction at B, VB equal to 7 by 64 WL. Therefore vertical reaction at A, VA equal to total load minus vertical reaction at B, that means VB, equal to WL minus 7 by 64 WL. You will get it as, if you take the LCM, you will get it as 64 minus 7 WL, it is 57 WL by 64. This will be the vertical reaction at A. Now I am finding out the shear force, section of zero shear. First of all I am finding out. So section of section of zero shear, I am finding out this. In this, what I am doing is, consider a section XX at a distance of x, at a distance of x from the fixed end A, from the fixed end A. Therefore, shear force at section XX equal to, you will get it as here, suppose I am considering a section XX here, and it is at a distance of x. So what I am doing is here I am having a reaction RA equal to RA into X, RA or VA, RA or VA into X. VA into X means the total length, whereas here it's not a moment, so RA or VA minus W into X for the UDL. So you will get it as 57 by 64 WL minus WX. This will be the shear force at section XX. For zero shear, what I am doing is shear force at XX. For zero shear, what I am doing is shear force at XX equal to 0. So shear force at XX equal to 0. That implies 57 by 64 WL minus WX equal to 0. If you solve it, you will get it as x equal to 57 by 64L. This will be the at a distance of x equal to 57 by 64L. The shear force will be 0. Now, the bending moment at B equal to 0. Why? Because if you consider here, there is a support and the bending moment at the B is equal to 0. Now, whereas at A, it's a fixed end. So, you will get the bending moment at A equal to here you get it as RB it is 7 by 64 WL. So 7 by 64 WL into its distance, it's 2L minus total load. If you see here, the load is WL into L by 2. Why? Because the UDL is only up to half of this span. From this, if you solve it, you will get it as minus 9 by 32 WL square. This will be the bending moment at A. Now, what I am doing is I am finding out the bending moment at D. So, bending moment at D, that is maximum positive bending moment, it will, you will get it as 57 by 64 WL into 57L by 64 minus W into 57L by 64 whole square into 1 by 2 minus 9 by 32 WL square. So for this, if you solve this, you will get it as somehow 945 by 8192 WL square. This will be the bending moment at D, where the maximum positive bending moment is occurring. Where the maximum positive bending moment it will occur means where the section shear force is equal to 0. Now I am finding out the point of contraflexure for the bending moment where it is changing its sign. If you see this, the bending moment at D, it is positive. So whereas in the previous you got it as the bending moment at A equal to minus 9 by 32 WL square. So now I want to find out where the point of contraflexure is acting. Therefore, point of contraflexure. Now what I am doing is I am finding out the point of contraflexure. For this I am considering a section where the bending moment is 0 at a distance of x from A. So I am writing it as 57 by 64 WL into x minus W x square by 2 minus 9 by 32 WL square equal to 0. From this, I need to find out the x value. So what I am doing is I am separating the x terms. 32 x square minus 57 lx plus 18L square equal to 0. That implies you will get it as some x equal to 0.41 L. This will be the distance at where the point of contraflexure is occurring. Thank you students. Thank you for listening this lecture. In this you can do some more also. Now I am drawing the shear force and bending moment diagrams for this. Sorry, I had forgotten that. Here what I am doing is I am drawing here. This is as a UDL of to a distance of point C, and it is L, and here this distance is L, and here you are having a vertical reaction at the end B, and here a moment MA, and a vertical reaction VA, and this end is A. So for this I am writing out the shear force and bending moment diagrams. So for shear force diagram, here I got it as some VA, it is 57 WL by 64, and here for at B I got it as minus 7 by 64 WL. So at C point what I am doing is I am extending this line here, and here up to this intensity you will be having like this. So this is positive and this is negative value, and this is the shear force diagram for this case. And if you consider the bending moment diagram for this A to B, here at point C you have to apply it, and if suppose if you consider here where the shear force is changing its sign up to this particular distance, it is 0.41 L. So here at the end A you got it as 9 by 32 WL square. So like this you will get it. This is negative value and this is positive value, and here you will get it as the maximum value you will get it as 945. The maximum value you will get it as 945 WL square by 8192. This will be the maximum bending moment here. You will get it here, and this will be the bending moment diagram. Thank you students. Thank you for listening this lecture. Hope you understood this lecture, and if you had any doubts you can feel free and you can give comments. Thank you for listening this lecture.